Alright, in this video we're going to do numbers 11 and 12. Okay, so 11 first. So a wind turbine has 3 blades, so it's a big windmill. It has 3 blades, each measuring 3 meters from the center to the tip. At a particular time, the turbine is rotating 4 times a minute. Okay, so we want to determine the angular velocity. So angular velocity is the rate of change of the angle. So the angular velocity of the turbine in radians per second. So not degrees per second, but in radians per second. Okay, and part B, how far is the tip of the blade? How far has the tip of the blade traveled after 5 minutes? So the tip of the blade's moving around, around. So how far will it have traveled after 5 minutes? Okay, so we're going to look at that right now. Okay, maybe you want to pause the video and try it first and then take a look at it. All right, so here is my bad version of a picture of a turbine. Okay, so there's the tower, there's the 3 blades for the windmill. One blade is 3 meters, and we need to know what RPMs are. Okay, so RPMs are rotations or revolutions per minute. So you can write it like this in words, or you can write it like this as a formula, basically. And in this case, it's given that the turbine is moving 4 times, rotating 4 times per minute. Okay? So 4 rotations per minute. Okay, so you can write that as rotations per minute. Okay, so angular velocity in radians per second equals, that's what we want to find out. So we want to look at this and we go, okay, how are we going to calculate this? Well, we've kind of got a velocity already. We've got a rate, right? We've got a rate that is 4 rotations per minute. Now we want to convert the rotations to radians, and we want to convert the minutes to seconds. So we've got to do this conversion, so we can do this quite simply. If I want to convert 1 rotation to a radian, or 1 minute to a second, I got to do the conversions for those ones separately. So the minutes, I want to change to seconds. So I'm going to put seconds on the bottom here. So I'm going to put equals seconds, and then at the top I'm going to put minutes. So I'm going to use this conversion. I'm going to multiply. So it's not equal, sorry, it's times. I want to get rid of stuff, okay? So 1 minute is 60 seconds. Okay, so that's what I've got for that. Now when I multiply this out, the minutes will cancel. So I'll get, and I'll be able to cancel it with that. So that will get rid of the minutes, and then I want to multiply by, well, I want to get rid of rotations and put rads. So where the rotations are, I want to put rads, and I want to get rid of rotations so it's on the bottom so that it will cancel out. So 1 rotation is equivalent to 2 pi radians. Okay, and then I can cancel out the rotations, and I'm left with rads, so I can cancel that out and that out. Okay, when I do that, this is what I've got. So I've got minutes cancel out and rotations cancel out. So all I have to do is multiply the top, multiply the bottom, simplify it, and I will have rads on top and seconds on the bottom. Okay, so that's what you end up getting. 4 times 2 times pi is 8 pi. 1 times 60 times 1 is 60, and that reduces, and you end up with 2 pi over 15 radians per second. So this windmill is rotating at 2 pi over 15 rads per second, or approximately 0.419 rads per second. And what does that mean? Well, that means about 0.419 radii per second. Okay, so that's pretty fast. And then you want to put a therefore statement. Okay, it's a word problem, so put a word answer. I'll let you work on that. All right, the next one is, okay, so we'll take another look at B. It was B, how far, so it's right up here, how far has the tip of the blade traveled after 5 minutes? Okay, so how far has the tip of the blade traveled? Well, the distance is going to be the radius times the angle, right? So the radius times the angle in radians gives you the arc length, because the angle tells you how many radii it's moved. And you multiply that by the length of the radius and you can figure out its arc length. Okay? So, well, the radius is 3 meters. We know that. That's the length of that blade, right? So that's 3 meters. And the angle, well, the angle is at 5 minutes. We know that in 1 second, it's moved 2 pi over 15. Okay, so we got to figure out for 5 minutes. So for 5 minutes, we've got 60 is 1 minute, so we can multiply by 60 and by 5 to see how many seconds it is. Okay, so in 5 minutes, this is the angle that it's moved. So you multiply those two, and it reduces to that, which is approximately 377 meters. Okay, so that's the angle that would have moved. That's the arc length that would have moved in 5 minutes, which we don't know how many rotations that is. We could figure that out, but we don't know how many it is. We just know that it's moved that far around the outside. Okay, so in there you got to put a therefore statement in there with the units and words and all that kind of stuff. I'm going to leave that for you to do. All right, so that's that question. The next one, number 12 on the same page. Textbook, I'll bring that question back up again. Okay, so 12. All right. So a wheel rotating at an angular velocity of 1.2 pi radians per second. So it's rotating at this speed in radians per second. So we have the angular velocity in radians per second. While a point on the circumference of the wheel travels 9.6 pi meters in 10 seconds. So we don't know the radius of it, but we know that on the circumference, this is how far it's moved in 10 seconds. So we should be able to figure out the radius from this. So it says, how many revolutions does the wheel make in 1 minute? Okay, so we know how many radians it goes in 1 second, so we should be able to convert that to revolutions in 1 minute, so RPMs. So this question is, determine the number of revolutions per minute. Okay, so we're kind of doing the opposite of what part A was in question 11. And then it says, what is the radius of the wheel? So then we've got to figure that one out. Okay, so let's do this here. All right. So we've got the angular velocity equals 1.2 pi rads per second. So the first part is we want to convert that to RPMs. Okay, and this is our conversion. So the RPMs is going to be, well, the angular velocity is 1.2 pi rads per second. We want to get rid of the rads and rid of seconds and replace it with revolutions and minutes. So we want to change this 1 second to minutes. So I'm going to multiply 60 seconds over 1 minute, and then the seconds cancel out. So this converts that seconds now to minutes. So if you just multiply that out, you'd get how many rads per minute there is. Now we want to convert rads to revolutions. Well, 1 revolution is 2 pi rads. So that's the conversion for that. Then you can cancel out the rads, and now you're left with revolutions per minute. Multiply the top and the bottom, and simplify. The pi's cancel out too, right? That canceled out with that pi. And then you have 36 revolutions per minute is the answer for that one. Okay, so therefore statement. Now, the second part of that question was, what is the radius of the wheel? Okay, so the radius of the wheel, you know how far it's moved around the radius in 10 seconds. You know the speed that it's moving, So we've got to work this out. Okay, so the radius is, well, 1.2 rads per second means that the point on the circumference is moving at 1.2 pi radii per second. So there's 1.2 pi radiuses in 1 second that it's moving, okay, which is more than half. Okay, so I wrote that as 1 point. It doesn't look like more than half, but you get the idea. Okay, so it's in 1 second it's gone 1.2 pi radii. All right. Now, the point moves 9.6 pi meters in 10 seconds. Well, convert that to 1 second so that we can work with it. So divide that by 10, so it's 0.96 pi meters in 1 second. Okay. So 1.2 pi radii equals 0.96 pi meters. And because it's moved in 1 second, it's moved that many radiuses. Okay, so 1.2 pi radiuses is how far the arc length is, and in 1 second it's also moved this many meters. So all I have to do is solve for r in this equation. So all I start solve for r, you divide both sides by 1.2 pi, and you get 0.8. So the radius is 0.8 meters. Okay, and that's it for the examples.